Good morning, Tolga and Zafer. Can you hear us? Good morning, Tolga and Zafer.
Good morning.
Only
Good
a check.
morning.
Only a check. Only a check.
Just checking the sound. Okay, Tolga is here and Zafir is here. Okay, everything set? Okay, so Tolga is going to be the second. The third is Zafir.
Yeah.
Sorry if I mispronounce your name, but hoping you understand.
Your pronunciation is good.
Quite okay.
Okay.
Okay, so shall we start with the session? We're a bit late. So shall we stay here?
Yeah.
Okay, okay. Okay, so the first paper is on implementation and proof experiment of communication network for disaster prevention using LPWA by Professor Kazuaki Tanaka.
Okay.
Oh,
I.
video is okay.
Okay. This is the slide.
Yeah.
PowerPoint. Yes. Sure. Sure. Screen.
Oh, yes, yes.
Slide PowerPoint. Okay.
Okay.
Please.
Good morning. I'm now talking about the implementation about the experimentation in local area in Japan for the disaster prevention using APRA. This is okay.
Yeah.
With the, yeah, okay. Okay, thank you. So recent days, the many disasters is occurred in worldwide many places. That is a problem. So how to prevent or how to reduce the disasters is so seamless communication or smooth communication. And in such disaster days, storm days, the power is down or communication line is also down. In such cases, more resilient infrastructure is needed. So my research and my presentation is about such resilient infrastructure implementation. So first of all, I showed about the field in experimentation. This is in Japan. I'm from Japan. In Japan, I now experimenting in the local area in Japan, western area in Japan. This area is heavy damage last year. Many rainfalls and landslide, and some people is injured. So that is a very serious problem in Japan because of the heavy rain and the typhoon. I show you the video. Sorry. I'm sorry.
Don't worry.
I
You
want to
can-
use the video.
Yeah. We share the video.
Yes, share the desktop, please.
Then very easy to stop sharing and then. Okay.
Yeah.
We shall share
Yes.
probably
Full
share-
screen. Yeah.
Yeah, it's better. So you can
Yeah, that is okay.
move from the video to the
yeah,
PowerPoint presentation.
that's good. That's good. Thank you. So this is a news video about the last year's disaster. So many landslide occurred and some house is broken. And you see the railway road is also broken. So very serious damage in Japan.
So back to the. Okay.
So let's continue. So landslide occurs. The landslide is because of the, of course, rainfalls, but the water containing in the land was soil is origin of the landslide. So point is how to measure the water in the soil and how to measure the rainfall strength and how to communicate or transmit to the headquarters or the servers, and how to announce or how to make an alert to the citizens is the solution of such disaster relation. So this is a measurement device using LPWA. LPWA stands for the low power wide area communication device. One device can communicate with under the several kilometers. So very long range is covered by one device. And the solar panel is generates electricity and charge and discharge cells. And rain meter or weather meter is connected. So the first point is a landslide for forecast. So how to forecast the landslide? From several sensors, rainfalls, rain strength, and soil pressure. Soil pressure that means water pressure inside the soil, inside the ground. And usually, so previous research, usually we can forecast in several hours before from the landslide by using rain strength. But the time is not clear. 24 hours or 72 hours is very unclear. So we cannot forecast using rain strength. And next is the water level of the river, or the river. This is the second choice of the forecast. But water levels in the river is very vary for the other reasons. So rainfalls, of course, rainfalls, but sometimes the distance from the measurement point is also cause errors. So this is also unclear. Soil pressure is a very reliable measurement of the landslide forecast, because this pressure sensor measures at the soil directly. But this measurement is only 30 minutes before the landslide. That is very close to the occurrence or event. So that is difficult. So we combine these three sensors and measure and forecast the landslide. So and also we use LPWA communication. This is a very strong against the electricity down or communication down, carrier communication down. So I'm using LPWA communication. So this is a network topology. This is a tree topology. The right side is HQ. HQ means the headquarters. This is a server or central of this LPWA network. And several devices, weather meter or soil pressure sensor or signage for the alert is connected to the headquarters by LPWA connection. And end-to-end communication is done by this research. So leaf to root is the measurement sensor. Sensor measurement value is transmitted to the leaf to root. And root to leaf is alert message showing on the signage. And also, security is important for such infrastructure, network infrastructure. But in this case, this is data signature is using for this time experimentation, not encryption, because message itself is that is not secret message. So that is sometimes alert, or sometimes that is strings, range strings or something. That is not secret. But network abuse is a very serious problem in this network infrastructure. So data signature is used. Yeah, this is a sending message procedure. Print message plus other random number and other message digest, then transmit to the destination. Destination can receiver can check the message is original or abused message, or they can distinguish. Or secure communication is done by this research. So transmitting time is of course some overhead is needed because of the message digest or such security, about security. But this figure shows about the transmitting message size, and x-axis is transmitting message size, and y-axis is time in milliseconds. So almost linear, and this deadline is this is the theoretical value. This means so this is that's the limitation of the hardware, and the blue line is under the Japan communications, Japan communications law. Under the law, such law, transmitting sending time is limited. So keeping such limitation is blue line. So dot is this experimentation. And also multi-hop transmitting is also available in this research. The blue line is direct connection, direct communication. So point-to-point direct communication. Red line is not direct, indirect communication. So one hop by some transponder repeater is the line. So almost linear. So as a result, we implement such a communication network infrastructure, and with secure and easy to use and low cost network. This network is without any licenses. So license fee is not needed. Then that cost is very low. So deploy and so continuously maintain the network is under the very low cost. This POC in Japan is 2 weather sensors, weather meter, and one set of the pressure sensor. Pressure sensor is measuring pressure in the soil, in the ground. So several depths is one set. Then measure each levels. Okay, I show the result of this. Yeah, this is so current now. This is a current so data from the that experimental field, and transmit by LPWA, and go to the and collect this server. And server value is we can see via internet connection. So so interestingly. Today in Japan now is 16, so 16 o'clock. Today we have a very heavy rain in Japan. Typhoon is coming to Japan. So heavy rains, we can see the heavy rains here. And in that case, in actually days, the temperature is not so high, and we can see the current condition of the experimental field like this. This is using the LPWA communication and collecting the server. Okay, now I'm trying to the future work about the using a pressure sensor. Pressure sensor is not shown, and now collecting only not shown. So pressure sensor using collecting and analyze and make alert is now future work. And disaster alert is a very important point of this research. So this year, this August and September, we are now planning the second experimentation in the real field and make a disaster alert by the data science. This is now planning. So this is my plan and my presentation. Thank you for listening today.
Okay, we have about 5 minutes questions and answers. So, the question?
Okay. First, me, very interesting.
Thank you.
As an environmental engineer that has studied on these natural risks, I'm very happy to see. And so, my question is, how can these sensors and this alert system can be implemented in a civil protection plan? In Italy, we use a lot of this type of plans, no? And Italy is known as a country known for the earthquakes, for landslides, for floods, no? And we have other system with civil protection plans. So, if you, how can these systems can be implemented to have a very quick information to the people, not to the experts, because experts know that in 30 minutes, in 50 minutes, must go,
It's too late.
it's too late, yeah, it's too late. But for the common people, no? That,
Almost real time.
it's they know the certain time when the risks happen or the landslides start.
Yes.
Thank you.
Thank you very much. So this API module can connect to several sensors, not only this weather sensor or pressure sensor, but also several vibration sensor is now running, and also the
Vibration sensor?
vibration sensor.
Something like 3D. What is it?
Maybe 3D, but now I'm using vibration on the ground.
Something like motion sensor?
Motion sensor, yeah,
Okay.
motion sensor. So like
Okay.
vibration is we can measure.
So that's for the earthquake.
Yeah.
So you combine earthquake.
Yeah, in Japan.
Everything is a disaster anyway.
Yeah, we love disaster, so we love.
Earthquake and the landslide is also landslide is that so slide the land, then the
Okay.
degrees are changing.
Okay, I have a few questions.
Yeah.
Because this is interesting, and I think you are going to. Where do you place this? Where do you place these sensors? I mean, because you know, in every place, even in rural or urban areas, they have this something like hazard map.
Yeah, hazard map.
So you place your sensors in the hazard map, right?
Yeah, of course. Hazard map, yes.
Hazard area.
So government provides us hazard map.
Okay. Then my next problem is if you're going to use this tree topology, so meaning you have one level, second level, third level, right?
Yeah.
So what happens if this server is in
that is a single
first one to
Fall down.
So why don't you adapt something like
Sorry. That is my explanation is so huge. I'm sorry. So the topology is the tree topology, but so continuously the reconfiguration of the network. So the best tree is current tree topology, but if some network is broken, then next time or reconfigured.
So
So
in
other-
a sense, you're already trying to apply ad hoc
yes,
network.
ad hoc network, yes.
Okay. So that's good. So if it is something like if this the current system something like gives some warning in 30 minutes,
Yeah,
because
yeah.
that's too it's very dangerous.
Yeah. That is no time to escape. Yeah.
So what a particular some level, right? Some
Yeah.
level that, you can issue a warning even maybe
Yeah.
in maybe
So,
5 seconds,
so we want to
3 seconds.
focus in this point,
Uh-huh.
more previous point or more before. One day or 6 hours is the best, I think, because 6 hours alert is sending to the citizens. Then
So,
they can
it's
decide.
something like proactive warning, right?
Yeah.
So you send the warning in 6 hours before.
Yeah.
So that's good.
That is okay to escape.
Yeah,
to
It's
the-
a good threshold. It's a good risk threshold.
Yeah.
Okay. Anything else? Okay.
Thank you very much.
Questions? So
Thank you very
thank you
much.
very much.
Thank you very much.
So we have to proceed to the next.
No,
Yeah, please.
Thank you. Okay. For the next presenter, by the way, let me introduce myself. I'm Bernardi Abduan from Bernardi Abduan from Kyushu Sangyo University, Japan, and I'm chairing this session. So the second paper will be presented online, and the paper is misinformation detection in social networks, systematic. Sorry, but the display is very small, so I can see. Systematic literature review. The paper will be presented by Zafar Duzen. Is it?
Yeah.
Okay. How can I change this one?
Okay. Zafar?
Yes, I can hear. Can you hear me?
Yeah. Loud and clear.
Can you share your presentation so we can?
Okay, 1 minute.
Yeah.
Okay.
Can you see it?
Yeah. Very good. Okay. If you're ready, please begin.
Okay, I'm ready. Good morning, everyone, and welcome to my presentation. Let me start by saying a few words about me and the author's background. I am Zafer Düzen from Istanbul, Turkey.
Sorry, Zafar. Sorry.
Let me just let you know that the presentation is 15 minutes and another 5 minutes
Okay.
for the question and answer.
Okay. I will try to finish it in 15 minutes. Okay, let me go. This is my outline. First, I will give a brief introduction and motivation information. Later, I will talk about the systematic review process. Then I will present my work and its results and finish the presentation and take your questions. Okay, since the emergence of social networks, traditional communication methods have been used less and digital channels have been used more. As you can see in the figure, approximately 5 billion people in the world using any social network. So social networks have increased news consumption due to their ease of access and broad audience reach and low cost. For this reason, social networks become the ideal platform for disseminating misinformation. And many studies developed for misinformation detection on social media, which achieved good results. Despite the growth of this type of research, it is difficult for a researcher to identify the most up-to-date literature on misinformation detection. To address this challenge, this paper represents a systematic review of literature. Okay, our motivation is like that. The spread of misinformation has been termed infodemic, and it's concerning that many people believe misinformation, and more than that is exposing this kind of information. So it is important for researchers aware of these existing solutions to problems when building this kind of system. For this reason, we decided to make a systematic literature review to help researchers to find out which are the data sets to use, what kind of solution are suggested in this area, etc. And so this is our systematic review process. First, we need to prepare our research questions, then we make our search and filters in the digital libraries according to the criteria we have defined. And then we determine all the studies that we will examine by analyzing the articles we have. Finally, we prepare our report on the results. Okay. First, we created our research questions. These are the questions of us. We try to find out how was the distribution of papers of misinformation detection distributed over the years, what types of publications have been developed, which social networks are mostly used, what kind of approaches are proposed for misinformation detections. We are trying to find out responses for these 6 questions in our library, in our SLR study. And we shared the digital libraries we used and their addresses. We identified 6 most used digital libraries. We used ACM, IEEE, Scopus, Springer, Web of Science, and Wiley to find out the related papers. After defining our search space, we specified the search phrases that would be used in electronic database search forms. The search was based on the static question, keywords, synonyms, and alternate words. Following you can see the search string which we used. Okay, we prepared a protocol for SLR study. So the inclusion and exclusion criteria have been established in order to accurately assess the quality of the available literature. So the paper should be in computer science field. It must be written in English. It must be based on last 10 years, and full text should be available for the application. This is what we need when we are filtering the papers. Also, after we identified the papers, we need to assess them for quality. So we defined some questions. These are written in here. I don't want to read all of them, but we are trying to assess our papers with these questions with a formula like that. The proposed quality assessment process consists of 3 main measures for quantitative purposes. A yes answer means it will receive a score 1. Partial answers receives a score 0.5. And if it's not related with the question, then we are giving that paper as a score of 0. Then we aggregate these all points and we order them and select our studies. Okay, we defined 3 phases. We utilize the form to categorize and record the information from each document. After searching the digital libraries using the stated research string pattern, the result of the search were also saved in an Excel spreadsheet and a Mendeley application. After extracting the population of scientific publications related to the study topics, the query returned 672 unique results at phase 1. Phase 1 consists of basically search with search string and implement the inclusion criteria. After then, we started our second phase. The second phase is reading the title, abstract, and results. Then we, on the filtered results, we make the full text readings for the third phase. So we defined the latest papers. At the end of this systematic review of the literature, we got 76 primary studies. This table shows the results of phase 1, phase 2, and phase 3 according to the digital libraries and the phases. And the results of these research question. Our first question was, how was the distribution of papers on misinformation detection, distribution over the years? And the first figure reflects the intensity of publications that propose to solve the problem of spreading misinformation on social networks. It is seen that the number of papers written on this subject has increased in 2016. Because when we search this, why this increase is happening, because it is predicted that one of the biggest reasons for this is the election results in America. It has been seen how effective misinformation is in people's political decisions, and as a result, the number of the studies has increased. Since the first 3 months of 2022 were taken into account while conducting this study, the reason for the decrease in the graph is due to the absence of the data for the rest of the year. So it is still increasing, in our opinion. And for the second figure, considering the distribution of articles by years and digital libraries from the second figure, it is seen that there are more articles in IEEE and Springer. And it is also clear to see that after 2016, from each digital library, it is increasing. For our second question, we try to answer what types of publications have been developed. And this is an overview of which types of primary studies are most published. Conferences and journals are the primary targets of this scientific effort. The fact that I think conferences have a more rigid structure of publication and a smaller scope than the journals, so we can understand that the larger number of papers published at conferences. Because of the review process of books, it is more time-consuming process, so it is lower count. It has lower count for the books. And we are trying to answer which social networks are mostly used as a case study. Actually, Twitter is the mostly used, and other than that, Weibo and Facebook as an environment for experimenting for that kind of studies. Besides that, the most used dataset is the fake news net for fake news detection. Also, I want to mention that. Also, we are trying to examine the domains in which the publication are being used. There are 4 primary domains we have discovered. Papers in this general category provide methods for detecting disinformation in social media posts using common variables such as the number of followers and particular linguistic patterns. The techniques in the news category are developed particularly to deal with the journalistic news. The health category contains method for disseminating health-related information. After the pandemic of COVID-19, this kind is currently the most prevalent one. And the politics category contains publication which are related to rumor spreading and conspiracy theories. This kind of misinformation can identify people's political decisions and cause polarization in society. Okay, also we try to find out what kind of misinformation exists in the literature. Actually, misinformation is not it is not means an incorrect is merely incorrect information. It can be propagated inadvertently, but sometimes source may not be aware of that. So we are using disinformation for misleading information. Also, some authors have listed disinformation as another subcategory of misinformation, but we have chosen this taxonomy. And we can talk about propaganda. Propaganda is the news that produced for scientific specific audience and is usually utilized in political setting. And conspiracy is stories that seek to explain a situation or incident by evoking some information. And these kind of ideas frequently present information with no known sources and untrusted sources as truths, and there are no evidence if they are true or not. For the rumors part, these rumors consist of news whose veracity never confirmed. These types of false information is widely spread on social media. Therefore, several studies have analyzed this type of news also. And that is done. And for our last research questions, we try to find out what kind of approaches proposed. Actually, recently, deep learning and artificial intelligence algorithms have been used more heavily. Also, some hybrid methods were applied in some articles, and better results were obtained in terms of performance. Researchers have used machine learning and deep learning methodologies in the majority of the situation with encouraging outcomes, but other researchers have used alternative techniques such as bidirectional encoder representation from transformers based on the natural language processing techniques. There are lots of that kind of usage existing in the literature. So our study questions revealed that Twitter, Weibo, and YouTube and Facebook are the most popular social media sites for that kind of studies. In addition to that, we can conclude that deep learning and artificial intelligence algorithms have been widely used nowadays. And finally, also it is determined that such as temporal or emotional resources together with or in addition to the text analysis can increase the correctness of the solutions. And for the future work ideas, we think that the publications generally focused on presenting studies for English language, so new studies can be done for non-English language misinformation detection. Also, fake news detection from images and videos standing out as problems that needs to be solved. Also for bot detection, it is needed, we think. Also for the real-time detection systems, especially when you are reading Twitter, you are seeing some real-time tweets and you can understand that kind of, if it is misinformation or not. You cannot understand that, and there are no study on that. And for the network dynamics based on the time analysis is also of crucial importance, so that how long does misinformation survive within the social network, and what kind of parameters of influence can be better inform our societies of is misinformation is spreading or not. And I also listed my 76 papers in here, filtered. We examine all of these ones. And these are my references. Thank you so much for your interest and attention. If anyone has any question, I would be happy to answer. Thank you very much.
Okay, thank you, Xavier. And do we have some questions from the audience? Yeah, yes, please.
76 paper.
We have.
No, please come to the microphone.
I cannot hear you very well.
Yeah. Professor is coming.
Okay.
Thank you for your presentation. Interesting. Hear me?
Yes, I can hear you.
Yeah, thank you. You said that you actually reviewed in the end 76 papers, right?
Yes.
Out of how many? Because I saw you also screen out some paper which probably you think not eligible, right? Because among the 6 questions, 6 or 7, I don't remember, and you also have to scroll out some paper which probably may not fulfill your goal, right?
Yes.
So
Actually, I can
example?
show you in here. Actually, we find out 672 papers at the beginning.
Right, so to speak.
Yes.
About 10%. Yeah, so it's very selective.
Yeah.
Not yeah, that's seems very interesting. So the result can be very robust because you only choose 10% out of the big sample. Yeah. Yeah, that's just my curiosity. Thank you very much.
Thank you very much.
Thank you. Okay, thank you. Any other quick question? Okay. Okay.
Quickly, very quickly.
Go ahead.
Very quick.
Zafar, a question.
Yeah.
Among this round of articles, have you found a particular article that produced misinformation and generates a wave among others and others articles? Thank you.
Actually, when I am working on this study, you mean some papers are uh, actually, I don't quite well understand the question. Sorry.
Okay, the question is only related to a certain or a clearer article that produced misinformation, no, fake news, or a particular scientific article that was considered the best, no, but it was the worst because produced misinformation, no, bad knowledge. And I know if you find them among your review.
Actually, because of these digital libraries are already reviewed by editors, I couldn't find that kind of stuff. But maybe if we check the other libraries, we can find. But I couldn't see something like that.
Okay, thank you. The last thing, I suggest you a program for review that
Okay.
its name is Bibliometrics.
Bibliometrics for
Yeah.
this kind of SLR studies.
It's a program specific to perform review. I
Okay.
suggest you this program because it's very useful for you.
Okay.
Thank you.
Thank you very much.
Okay. Thank you very much. Okay. So
Can I stop sharing?
Yeah.
Okay.
Okay.
then we move to the next speaker. Okay, Tolga, you're going to be the next speaker. Can you hear us, Tolga? No. Yeah. This one?
Mute. 3 dots.
Oh, that's already mute. Unmute. Unmute. And then this one is mute. Okay, can you hear us?
Hi, everyone.
Okay, thank you. Kindly share your screen.
I try to share my presentation. Can you see my presentation?
No, no.
I try to reshare. I'm selecting my PowerPoint presentation, but you are not showing anything.
Yeah. We don't. We cannot see anything from your side.
Probably is better than you share your full screen and not only the
Okay.
window related to PowerPoint. Is better.
The whole screen.
Okay, I'm sharing. I'm sorry, I'm trying to share my screen. I'm trying to share entire, but there anything change? Sorry. Let me. I try to.
Okay. What we can do is, so we move to the next speaker, and then after the next speaker, you're going to be the
Okay,
last
thank
one.
you, thank you.
Okay. Okay, that's good.
And Tolga,
Yes, sir.
probably if you can, generates a PDF and not PowerPoint presentation. That's
Okay.
better.
Okay.
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 See you
Thank
soon.
See you soon.
Okay. So okay. But
There's no more.
where's the screen?
Yeah, I share its presentation.
Hmm.
Okay. Okay. Toshiro. I only ocultar. Okay. It is yours.
紹介
あ、どうぞ。
紹介したらいいですか
どうぞ。
Okay, I'm Toshiro Uchibayashi from Japan. I talk about third container migration data auditing mechanism for edge computing environment. Introduction. In recent years, sensors and devices have become remarkably popular, and a wide variety of sensors and devices are available in the market. The Internet of Things, in which data collected by sensors and devices is stored in the cloud via the edge, has become common. GH will be indispensable for pre-processing large amounts of data at high speeds in the future. At GH, applications are running in virtual machines and containers. These virtual machines and containers can be managed as images and developed to a large number of edges. Images can be extracted from running edges and easily developed and migrated to other edges. The mechanism for developing and moving virtual machines and containers does not take into account the conventions and regulations of the applications and data it contains. A possibility of violating application conventions and national laws, whether intentionally or unintentionally. A virtual machine can be solved by our proposed mechanism. A container can be addressed by extending the virtual machine solution. Yes. This paper focuses container. So data auditing for VM migration. We proposed and implemented the data auditing mechanism for live migration of virtual machines in the cloud. VM migration has become indispensable technology for cloud operations. However, the migration process is simplified and can be easily performed as long as the cloud permissions are met. This only determines the cloud's authority and whether it is physically possible to migrate and does not take into account any of VM's internal data. Possible intentional misdirection of VMs and malicious movement of VMs. Possible violation of company policies and national laws depending on the destination. Need a control mechanism that determines whether or not VM can be migrated, taking into account not only the cloud permissions and physical availability, but also the data that the VMs contain. So propose a policy-based control mechanism to solve the problem of inappropriate, sorry.
live migration of data contained in virtual machines. This is migration auditing mechanism. So VM manager describe regulation. So contain country data organization code. So host machine manager describes country and organization. Country have country code. Organization have organization code. So if migration, so compare regulation and country and organization code. So permit or deny, decide permit or deny. Implemented and evaluated the proposed mechanism in a cloud environment. Evaluated whether the decision of whether or not to perform policy compliant VM migration is correctly made, and confirmed that it is correctly made. Measure the execution time of live migration using the proposed mechanism. Shows that there is no overhead cost. This paper extends our proposed mechanism targeting VMs in the cloud to containers at the edge. Container migration. Containers which are much lighter than virtual machines are attracting attention. Web application previously realized with virtual machines are being migrated to containers one after another. Furthermore, as edge computing becomes more prevalent, the demand for containers is increasing. Container migration is attracting attention. Edge nodes, which are much less powerful than the cloud, often use containers. However, due to their limited power, they cannot handle multiple containers at the same time. And the container processing must be moved to a neighboring edge node. Container migration can be used to migrate containers to another edge node with current process flows, and then restart the containers to keep the environment intact. We considered inappropriate data movement to be a concern for container migration as well. Unlike VM host machines, there are no abundant resources at the edge, so hardware requirements are needed in addition to information such as organization and country. So our proposed mechanism as hardware requirements to the data audit requirements such as organization and country are proposed for VM migration. This is a proposed mechanism. Container owner create and update container policy. Container policy in container. So edge computing device owner create update edge computing device policy in edge. Container policy has two auditing methods. Data auditing, hardware requirement. So data auditing have two elements. Hardware requirement has 9 elements. Edge computing device policy has also two data auditing hardware requirement. So data auditing has 2 elements. Hardware requirement has 8 elements in edge computing device policy. This is container policy element and description. This is edge computing device policy, element and distributions. So during container migration, the policy in the container to be moved is compared with the policy of the destination edge to determine whether the migration is feasible. If the destination edge meets the requirements of the policy in the container, the migration shall be performed. This is implementation environment. 8 edge device and 4 regions. Up one container running on edge 1. This is policy. So container and edge device. So this means permit JP US country. Container permit organization 134. So container, upon container permit running, so H1, H2, and H7 and H8. The execution time measured when the container is migrated from H1 to H5. Verify how much difference there is in execution time with and without the proposed policy mechanism. With policy mechanism, 220 milliseconds. Without policy mechanism, 217 milliseconds. The effect of the policy mechanisms on the migration time is very small. Therefore, the proposed policy mechanism is practical enough. Conclusion focuses on containers and their migration, a rapidly growing area of demand in recent years. Proposed policy and auditing mechanism for container migration and relocation. Evaluation of the proposal system in the edge computing environment showed that the addition of the proposed policy mechanism had a very small impact on migration time, and that the system was sufficiently practical. In the future, we would like to test the proposed system in an actual wide area network rather than in a very compact short-range environment such as the ones used in this study. Thank you for attention.
Okay, thank you. Since the next session will start at 10:30, then we have one question. One question. Yes, sir. But the next session for the whole thing is scheduled to start at 10:30, right? Yeah. So for this talk, you can have it. Because there's one more paper. Any? Quick question. I cannot ask question because I'm not causal with it.
終わりましょう。終わりましょう。時間がやばいと思います。
Okay, not unless no questions, then we proceed. Okay. Okay, so how are you? Tolga, how are you?
Thank you. I try to reshare my screen. I hopefully I will done.
Sure.
I'm sharing my entire screen,
Toshiro, thank you.
but they're ending.
Oh. You're doing it already?
No, I'm sharing, but any interaction I'm getting. No, there are no interaction. If you want, I can share my presentation with email. Can you open there? I can present.
We don't. We we haven't here email box, or better, we need to talk with the technical assistants to solve this problem. You can send them an email, okay? Not here. Not here.
I'm
because,
using MacBook, and my Explorer
probably
is Google
probably
Chrome.
probably I think that you have more than one video, yes, or you have one laptop, or one laptop with the 2 or 3 videos. Video
Okay,
screen.
why don't you close all the other windows?
Yeah.
Yeah, I'm closing, but okay, I'm trying.
Close the other windows and then just
I'm
concentrate on
closing the other
Yeah, yeah.
windows.
We have
Okay.
multiple screen. So the system don't recognize what screen I share.
Mhm.
Move right to left, left to right.
Yes, I have a tab. This live videos URL is open, and my PDF is only open. Any other tabs or window is not connected to my computer.
So
I'm
you share.
trying again.
You cannot share.
No, I'm pressing the share button, but any interaction I'm showing.
Oh,
Chat. You can't also send us via chat the PDF presentation.
Okay,
Can you try? But I
I
don't know.
didn't
Probably
send file. I think I didn't send file. I think in chat.
in the box.
If you want, I can send you
yes.
email.
Please send the file in the chat.
In other words,
Mm.
no problem.
Mm.
We talk with the platform or
Mm.
Damiano
Mm.
say that about this situation
Mm.
and then
Reschedule. Schedule.
reschedule.
Okay, so since we are losing time because there's another session coming in,
But
the next session coming in, then we will probably talk with technical stuff, and then
okay, I'm trying to close the window and open again. That's last thing.
Probably coming, come on, coming.
I'm
maybe
here again.
turn off this one.
I'm trying to share.
We see your screen.
But you are seeing my.
Now, if you on Chrome open your PDF, it's better.
Okay, I get it.
So we can start because we are a bit on late.
Very late.
Sorry. Okay. I'm only sharing my Google Chrome screen. Do you show
Okay.
There we go.
Tolga.
Okay,
Go fast.
full screen, full screen.
Okay. Hi everyone.
Full screen.
Sorry this latency. My name is Tolga Büyüktaner. I'm working at Lodos Technology RD department. This study is supported by Lodos Technology and Yıldız Technical University. Sorry. SLR and systematic literature review or systematic mapping study aims to review all the primary studies to identify, classify, and compare the research area and answer the question. Sorry. Answer the question. In the study, we try to provide a clear perspective to literature for future direction. This approach is users' request in the future, near future can be predicted from previous access data, and responses to the request can be fetched into the cache. This approach is called as prefetching. It aims to minimize user access latency and using optimum memory and bandwidth. Web prefetching and mobile prefetching is hot topic. Has been studying over and over again with novel prediction approach for the near future. There has not been a systematic literature review on the literature. Mobile and web prefetching that would identify publication trends, research gap, and future direction. In this presentation, we are starting to our systematic literature review process. On the screen, you are seeing our research question and their main motivation. We define the research question to obtain literature knowledge and to give form to the review process. I'm going to the next slide. Firstly, we create search string to find primary studies. Using the search string, we collect results from 4 digital libraries such as IEEE, Science Direct, ACM, Springer Link. We collect 469 study from these libraries. After then, we applied our filters. We use Zotero application, but I'm not that in the Zafer presentation, someone says another tool, alternative of the Zotero. I'm not that. After downloading studies, we applied predefined 3 filters, and end of the filtering process, we get 102 study. We applied in this systematic literature review study, we collect search results and eliminate the results according to our filter, and then our inclusion and exclusion criteria. In this presentation, we displayed we are displaying our inclusion and exclusion criteria. We included studies which are include prefetch term in abstract or key in abstract or in keywords. If mobile or web prefetching topic is clear in the abstract, we included it. We excluded blocks and presentation, and hardware-based and network-based prefetching studies. We classified 102 studies in 3 categories to data extraction form, research issues, prediction method, and prefetching plays. Fields were not filled during data extraction unless clearly defined to avoid assumption. At the beginning of the data extraction process, we selected a few studies randomly. Then we extract data from the same studies set according to this form displayed in the presentation, we did cross-checked, and we couldn't detect any conflict. After realizing everything was fine, we started to data extraction process. In the following slides, we present our results, and we try to find out we try to answer our research questions. Our first research question is about main practical motivation behind using prefetch. The main motivation of the prefetching is to satisfy user and service providers. The frequency of primary studies by year is shown in the figure on the presentation. According to figure, the number of publication has decreased in the last 5 years. This result seems to be incompatible with search results of search string on Google Scholar year by year. We try to extract prediction approach for prefetching from obtained primary studies to answer this research question. We read studies profoundly and found out a prediction approach in the prefetching module. We classified the prediction approach under the several class, such as clustering based approach, association rules based, statistical based, classification based approach. And in some studies, they implement their custom approach. We define as a class them. We classified the research issues on prefetching as follow: computation intensive operation, network traffic, long resource loading time, energy consumption, security, and privacy. Some studies contains more than one research issues. Network traffic, long resource loading time, and energy consumption issues are hot with the new prediction methods. According to figure, computation intensive operation and security and privacy for prefetching are less studies. So these may present opportunities for identifying future research direction. In this slide, we present the journal names. They are accept papers on mobile or web prefetching topics with their Scimago journal ranks. We discuss the threats to validity of research in this slide. We search prefetching terms with mobile and web words separately on digital libraries, and we collected results with snowballing, but we have not accessed all related studies, so we cannot guarantee that. This study is systematic literature reviews, but our research questions may not be cover all the literature in details. The data extraction was done manually using Zotero application. Therefore, our decisions are incorrect. However, we cross-check during the extraction process and talk together and decide together. In this presentation, we discuss conclusion and future works. The main contribution is to present the state of the literature about mobile and web prefetching by analyzing the trends on this study. Almost equal number of studies are added to the literature each year, so it can be we think that the existing prefetching approach do not fully solve the problems. We think there are some problem can be solved with prefetching approach. Prefetching approach, prediction approach for prefetching is categorized in order to help to find new research areas. We also define future direction and research issues in this study. We conclude that the mobile or web prefetching topic is open to new contribution with new approach, and the some topics because of lack of studies. Research on security and privacy and prefetching for computation intensive operation may give good opportunities, because in these topics there are less because of the lack of studies. So we will focus on these topics in our future works. Thank you for your attention, and I'm sorry about the latency.
Thank you very much. Really, really a quick question, because the next session is going to start. Anybody? Anybody? Yes.
Yeah, I
Good.
little question. You give us a certain definition of prefetching, no? But in your opinion, you use this definition
Yes.
from the survey as a definition extracted from your survey, that if I see I saw good, started in 2001, and if you come back, I don't know, in 19th, this definition can be modified or be the same. Thank you.
Sorry, I didn't understand your question very well. Can you define?
You give us a definition of a profession, no?
Okay.
Okay. And your review started in 2001, yes or not?
We focus on prefetching is working on a lot of area in the information technologies, but we focus on the web and mobile prefetching. Our main is users' request in the near future can be predicted from previously accessed data, and responses to the request can be fetched into the cache. Our prefetching definition is that.
Okay. Thank you.
Okay, thank you very much, Tolga.
Thank you. I'm so sorry again.
No problem. Okay, so before we have about 5 minutes toilet break.
That's yours. I share the screen. So
Just share the slides. Ooh.
our loop. Only. Okay. So
I'll probably have to do this because I wanted to make all. Okay, let me just sit. Okay, can you hear me? Online guest, we don't have online, but there's one paper, right? Online. Okay.
Because
Okay.
we are only present.
Okay. So, okay, the first presentation of this session, session 5C, is titled "A Framework of an RL," that stands for Reinforcement Learning Based Task Offloading Mechanism for Multi-Users in Edge Computing. This paper is actually written and by these two guys, and the first author is actually my former student, but since he cannot come, then I will be taking the presentation on his behalf. Okay, so if there's another question that cannot be answered in this platform, then you can just email him. Okay, so this is the outline of the presentation, and then so what happens next is we have the introduction, objectives, proposed mechanism, experiments and results, and as well as concluding remarks and future research. Okay, if I guess everybody already has an idea of these IoT devices, which are actually used in IoT applications. Just like the previous speaker, Professor Tanaka is using actually IoT devices to sensor, right? For sensors. Okay, so there are so many applications of IoT devices. So, but these IoT devices, since they are, I mean, they don't have something like a processing power of their own, so they have to rely on the servers to process the data. Okay, so these IoT applications have very wide applications, especially in smart cities and something like disaster preventions and all these kind of things. Okay, so this is on the left, and the figure one is the trends and forecast in the number of IoT devices worldwide. Okay, as actually this is actually compiled by this Ministry of Internal Affairs and Communications in Japan. Okay, so because of this IoT applications that requires processing high power processing, then most of these applications, although not really all, but many of these applications require real-time performance. That is, say for example, self-driving cars and surveillance systems and all these kind of things. Okay, so since this type of applications actually requires a high processing computing resources, then the cloud is actually the solution that provides the solution for this high performance computing resources. However, because there are only a few data centers, cloud data centers in every country, so there's always a possibility that this transmission of data as well as internet connections, and something like communication overhead will actually takes place because of the distance between the device and the data center. Okay, so the one idea, okay, one recent, it's not recent actually, but one idea to cope up with this problem of transmission delay and so this computing power is that they utilize this paradigm, edge computing paradigm. That is, this processing of, instead of processing the data in the cloud, then it's the processing will be done near the devices. Okay, near the devices. So we can actually eliminate this communication overhead. Okay, so this is how it looks like in. So we have this state-of-the-art edge computing. Okay. By the way, edge computing is not actually a replacement of the cloud, but it's actually a complement of cloud computing. Okay. So this is how it goes in edge computing system. So you have different edge devices, and you have edge nodes or edge servers, and you have the cloud data center. So in this particular, okay, let me. Okay, this is laser. Okay, so here we have the edge devices, edge nodes or servers, and then the cloud data center. So we have this edge devices sending their individual data to the nodes or the edge servers. Okay, so but then these edge servers compared to the servers in the data centers are far below the performance of the edge servers at the data center. So what happens is that if this edge server is going to receive lots of data, okay, a huge amount of data from different sources, then it can process, but however, it takes a long time. Okay, and if you are looking for some IoT real-time applications, then it wouldn't serve the purpose. So what happens is that part of this data accumulated in this particular server, part of it will be offloaded to the data center. Okay, offloaded to the data center, and then in the data center, that part will be processed, and then the result will be sent back to this edge node or this edge server. But then you still have this communication overhead, or probably internet connection, something like on and off internet connection. So that can probably propose some problems. So what happens is that this is still a problem. So what we are probably thinking is that instead of sending this part of the data to be processed in the cloud data center, then we actually have to send this portion of the data to the nearby edge server. Okay, so we call it process computation offloading. Okay, it depends on the case. It could be offloaded. Part of it could be offloaded to this particular server. Another part could be offloaded to this particular server. Okay, so it actually lessens the processing load of this particular server, and then hereby something like shorten this total processing amount of time. And so this is the purpose of this study: provide an optimal resource allocation to user devices by adapting continuous value in task of loading decisions in edge computing environments. Okay, so this is some studies in offloading are actually using this discrete values, but in our case we are using this continuous values. Okay, so these are the advantages that have seen why we're going to use this continuous values instead of discrete. Okay, so okay. Next. Okay. Oh, okay, so we have made some surveys of some related works to this study. The first one is this first reference Q-learning based task of loading resource optimization for a collaborative computing system. These authors actually designed a Q-learning based task of loading policy, and they have number of states dimensions which increases exponentially. And then other paper, deep reinforcement learning based method for mobile data offloading. These authors propose an offloading method using deep Q network, and it's also a discrete action space. And the other one is edge computing, using autonomous decentralized task offload. These authors propose an autonomous distributed task offloading method, okay, and to provide distributed processing that can be cope up with increasing number of moving applications, and as topology changes. Okay, so our task then is we have more or less similar purpose of this research, but the big difference is that we are using this discrete behavioral decisions for task offloading. Okay, so that's the big difference between our study and the related works. And so this is the system model. Okay, this is the system model that we have. So you have different tasks generated by different devices. Okay, and then you have the server. And then if the server cannot cope up with this processing load, then it can offload part of its the task uh, to other servers, other nearby edge servers. Okay, so that's what we call task offloading or computation offloading. Okay, so we actually based this study on reinforcement learning. Okay, reinforcement learning. I think many of us already know what reinforcement learning is. It looks something like this. Okay, so you have the agent and the environment, and then the reward. So this is something like the model. Okay, you have something like the model. So okay, so. The distribution problems, task distribution problems can be defined as combinatorial, combinatorial optimization problems. Okay, and reinforcement learning is an effective way to solve these types of problems. Okay, so from this figure, we have the agent, the state, the action, and the environment. They are actually defined through this. Okay, these are the definitions of these different items. Okay, it's for the agent, and then we have the state, we have the action, and then we have the environment. Okay, so we also make use of this Markov MDPs, Markov decision process. So because we model this representation of time series translation in reinforcement learning with MDPs, so we can maximize the cumulative reward by simply finding the function applied by the MDP. And this is our main mechanism, which is used for this offloading mechanism. Okay, it is based on this DDPG, deep deterministic policy gradient. Okay, so we have this kind of actor network, actor and critics. The DDPG is actually defined by actor and critic networks. Okay, so the actor network is actually deterministic policy functions, means deterministic for a given state. Okay, and the critic function network is a function that critics the action chosen by the actor and estimates the value function. So in the experiment environment, we actually conducted the experiments in a simulator. The guy and my students actually developed this simulation environment, and these are the simulation parameters that were considered in building this simulation system. Okay, so this is our objective in building the simulator. Okay, to evaluate the task offloading mechanism according to DDPG algorithm and allocates tasks to optimal edge servers. So for the training data sets, because you have this in machine learning and deep learning, you're going to have this type of models, right? And then with this model, you tend to have this kind of data set in order for this model to learn. Okay, and for this particular purpose, we use this crowded mobility data set. I think this can be you can Google, and probably this is also mentioned in one of the references. Okay, this is the data set that we have considered for training the model. Okay, so crowded is a mobility data set which shows mobility devices like smartphones and wearable devices generating tasks at regular intervals. Okay, so we have this coordinates Okay, we have conducted some experiments, and let's first decide this x and y axis of the graph. Okay, the y axis stands for the reward. So it's actually the evaluation of actions selected and performed by the model. Okay, and the x-axis is the episodes. Okay, an episode is a series of attempts from the initial state to the end state due to task completion or failure. Okay, so these are the graphs that we have acquired. Okay, that we have measured, and we actually have divided this into number of user devices, 30 user devices, 50, and 80. Okay, so each of these observations using different number of user devices. This is actually just another view of the results, and with the 30 user devices. So we observe that the reward tends to increase continuously, okay, which indicates that the post mechanism in the environment can offload tasks to the edge server appropriately for the user devices. And with 50 user devices, it's more or less the same with the 30 user devices, but we can observe that the range of rewards is lower than in the case of 30 devices. Okay. This may indicate that some episodes may have dropped out because they could not offload the task appropriately. And with the 80 user devices, there were some episodes that may have high rewards, but the overall rewards are highly variable. And it is difficult to say that the rewards are on increasing trend. This may be due to too many devices offloading tasks relative to the number of servers in the experiment environment, because we have limited number of servers. Okay. So these are the current issues and future research of the paper. Okay, so evaluate the versatility of the variety of tasks and employment environments, and also conduct similar evaluation experiments in real-time environments. That will be one of the future works. And so these are the concluding remarks. We have describe this offloading mechanism using DDPG algorithm, and then we built the simulation environment and then conduct some offloading experiments. And then so for future work, then we have this. We try, because we didn't consider actually the computational power. It's the servers that we have used is actually of the same type. So we didn't have something like a different computing power of different servers. So there, at this point in time, the experiment we only have used uniform. Okay, so that could be if you are going to be close to reality, it should be something like different computing power. Okay. And also the offloading methods, because we have these three types of offloading methods. Okay, we have the local execution, partial offloading, and full offloading. Okay, in this particular experiment that we had just conducted, we have done something like full offloading. Okay, full offloading. Okay, so I think that's going to be enough. And then okay, it's time. Okay, any question? Yes.
I'm curious. Curious. A small question. In the final slide, in the last final slide, no, you talk about the mobile devices, no? The mobile devices that you will consider in the future perspective of your work are including smartwatches, mobile devices are included all types, wearables,
yes,
telephones.
Yes, but the thing is, that could be a very nice environment. But the thing is, that's going to be very complicated, because the thing, different mobile devices have different.
So,
But that's good. That's good. But it's going to be very hard.
Thank you.
Okay. Anything else? Okay. Okay. Not unless you have questions, then. Okay, you're the next. Can you check that? Yes.
Okay. This one works.
Yeah,
Okay.
it works.
I check only the microphone is good. Okay.
Okay, once you're ready, please go ahead.
Okay, so thank you very much for attending this presentation in person or online. I am Professor Ali Idri. I am a professor from University Mohammed V in Morocco, and I am presenting on behalf of my two PhD students, Fatim Zahran Qash and Hasna Zarwawi. So the presentation is titled Random Forest-Based Deep Hybrid Architectures for Histopathological Breast Cancer Image Classification. So the main idea is to compare one of the well-known Bayesian ensemble, which is random forest, and how random forest can improve the performance of classification breast cancer images, in particular histopathological images. Okay, so this is the agenda of my presentation. First, the introduction, motivation, and objectives of this study. The background in which we explain the feature extractor that we used, and also the random forest, data preparation, empirical design. Then we present the result and with the discussion and conclusion and future work. Okay, so as you know, breast cancer became the most common cancer, and around 12% of all new annual cancer cases worldwide are have this type of cancer. So this is why, with the advancement on artificial intelligence, in particular in deep learning and in computer vision, the idea is to use these tools in order to help doctor for detecting the breast cancer earlier, so the treatment can achieve a good result. So this work is an extended work of a paper that we have published in a journal. And the paper is about evaluating the use of hybrid architecture. Hybrid architecture means that we are using deep learning for feature extraction. So to take advantage from deep learning as rather than the use of classical image processing techniques, and also take advantage from machine learning techniques in terms of classification. So this work extended the last one in that we compare the ensemble learning, in particular random forests with trees, in order to know if ensemble perform better, and in particular random forests in this for breast cancer classification based on histopathological images. Okay, so this is the main objective and the research question that we are dealing in this study. So we develop and evaluate and compare different hybrid architectures. Random forest as a classifier, for which we try four configuration using three learners, 5, 7, and 9. And we used only three feature extractors. As I said in our previous work, the main finding was that DanceNet, Inception V3, and Mobile V2 were the most accurate in terms of extraction the feature. So we have here four research questions. The first one is the classical one that you can find in any study comparing ensemble with single techniques. So do hybrid random forest model perform better than their trees? I mean their singles. Second question is, what is the best number of trees of the outperforming hybrid random forest model? So the idea is to compare is to evaluate what is the impact of the number of learners that we can use in a random forest classification.
The third question is to compare random forests and a global decision tree without sampling the data sets. And the last question will be about what is the best hybrid random forest model for each magnification factor. As you know, the BRIC-HIS data set that we used in the study contains 4 magnification factors. 40, 100, 200, and 400. Okay, so as I said, we use transfer learning and we use tree CNN architecture, DenseNet, MobileNet, and Inception for feature extraction. And we used random forest for classification. As you know, random forest is a particular case of Bayesian. The Bayes that we used here is 60% of the overall data set, and the number of Bayes ranged from 3 to 9. So we have 4 configurations of the random forest. Okay, so before mining the data in order to extract the knowledge, we should prepare data. And we do some classical tasks. The BRIC-HIS data set contains 7,909 images, histopatological images. And we have 4 magnification factors, as I said, 40, 100, 200, and 400. So this is an unbalanced data since we have 2,008 benign and 5,029 malignant. And this is normal because this is a diagnosis data set, so you will find most of the cases are positive. And this is some tasks that we did in the pre-processing, intensity normalization, and clarify for the contracts to improve the quality of the data. And for data augmentation, we did some method, rescaling, rotation, horizontal shift in order to have more instance in the data to overcome the problem of unbalanced data. So this is quickly how we apply data preprocessing. For example, here you have the original images after intensity normalization, and the third one is after using the Clahy method. And this is for data augmentation to overcome the problem of unbalanced data. So we use the rotation, vertical shift, and horizontal shift, and other. Okay, so for the evaluation process, we used the 5-fold cross-validation. And we used 4 criteria to measure the performance, accuracy, sensitivity, specificity, and precision. 5, and the F1 score. We used the Scott-Knott test. This is very important to test the significance, if the difference is significant, to say that this model is better than the other. And we used also the border count. This is a voting system in order to make a global rank depending on the 5 criteria. Okay, so this is the result that we obtained here. For example, the research question 1. Do hybrid random forest model perform better than their trees? So you see here you have 4 cases because you have 4 magnification factors. And for each one, you have 3 blocks because you have 3 feature extractor. For example, this one is the block for DenseNet. And you can see you have 4 bars that counts the difference between, in terms of accuracy, between the random forest and the average of the single. So as you can see, in general, the difference is positive, which means that ensemble perform better than their single. And we did in order to test if this difference is significant. We used the Scott-Knott, and in all cases, we found that random forest perform better, maybe in 2 exceptions in which we have random forest is similar to single. This is the case with magnification factor 100, for the case of the DenseNet and the case of MobileNet. And this is the question for what is the impact of the number of learners in the random forest classifier. So you have here also 4 blocks, and for each one you have the comparison according to the future structure. And you can see here for the pink color, which is with number of learners 9, we can see that in general that more the number of the learner is higher, more the accuracy is higher also for the random forest, except for 2 cases when we can find that it was similar. This is the case of random forest of 9 trees, and the case of 2 MF200, this one in the case of DanceNet, and in the case of 400 MF 400 in the case of MobileNet, this one. So this is the only cases when we found that 7 is similar to use 9 learners. Okay, this is the question, the result of the question about comparing random forests with a global decision tree without sampling the data sets. So you can see, for example, here you have in this column you have the magnification factors, and here you have the future structure, and you can notice that any value, for example, if we consider the case of for magnification factor 40. For DanceNet, you have 83, but for the single DT, you have only 79. So all the values in this part are higher than the values of the case of using single decision trees. And this is a comparison of what is the best hybrid random forest model for each MF. So for each magnification factor, and each we consider the best technique according to the previous research questions. So here you have the table. For example, for the magnification factor 40, the first rank is random forest with inception and with number of learners 9. So as you can see in this column, in most cases, this is the random forest with inception as a future structure and 9 learner, which except the case of 100, where you have random forest with DanceNet. So we can say that in general, for any magnification factor, random forest using inception as future structure with 9 learners was the best. Okay, this is the last question on what is the best hybrid random forest, whatever the magnification factor that you have used. So we have 4 cases because we have 4 magnification factors, and for each one we select the best one. So as you can see here, in most cases it was the random forest with inception with 9 learners is the best, and in particular for the case of 200, and following the case of 40, 100, and 400. Okay, so this is the conclusion. What the main finding of this study. First, that according to LQ1, ensemble perform better, and this confirms what we have in the literature. The number of singles has increased, the higher accuracy is. And for the best random forest perform best than the decision tree when you consider all the data sets. And for the magnification factors, it was the case of 200, in which we obtained the most accurate classifier. So for the perspective, we are looking for implementing hybrid Bayesian ensemble for other single, because random forest is only for decision tree. So we are doing the same for multi-layer perceptron, for canary snipers, and for super vector machine. And we will compare what is the best Bayesian technique. And also, as a second objective, we are looking for comparing bagging and boosting, as boosting is another version of ensemble, in particular homogeneous ensemble, in order to evaluate what is the best case in case of breast cancer classification, is bagging or boosting. So thank you very much, and if you have any questions.
Thank you very much. So do we have questions, comments from the audience, please?
A question. You performed this application for the breast cancer, no?
Yeah,
That is the first cancer probably in the world
Yeah.
for the typology, unfortunately. But this technique can be applied on other typology of cancer with the same accuracy, with the same resolution.
Yeah, for sure. Since the hybrid architecture and any machine learning techniques depend on the context. I mean, depend on the data set, how many features, how many instances, performance will change. But we applied the same experimental design, not in another cancer, in diabetic retinopathy. And we found the same that bagging is best, in particular random forest. We apply it also, I forgot, in cervical cancer. This is one of the most well-known gynecological cancer. And we found the same, that maybe bagging and random forest will perform better than single. So, but not with the same values. Maybe can be lower or higher, but it's still one of the most modeling that can allow a high performance.
Anyway, we got the results.
Yeah.
Thank you.
Good question.
Comments? Okay. Just I saw something like one of your slides. You mentioned about data augmentation.
Yeah.
So are you also doing some sort of data cleaning?
Data cleaning was in the first, because data augmentation, the main objective is to overcome the overfitting problem, and in particular the unbalanced data. But we do for cleaning the images, we do this two tasks: intensity normalization and improving the contrast of the image through the climate. Only these two, these two techniques.
Okay, thank you very much. Anything
Thank
else? Okay, thank you, Professor. Okay, let's proceed to the next speaker. That's an online.
So the last one is Mattia. Mattia, are you with us?
Hello, Mattia. You're going to be the next speaker. Mattia. I don't know how to pronounce. Okay.
No, Mattia. You're mute. I unmute you.
Mattia, are you there? Is this a name of male or female?
Send a message.
Hello, Mattia. Are you there? Sushi. It's another guy.
Mattia. Probably.
Hello, Mattia. Are you there?
Microphone
or she is not around. Is that a name of a female or male? Male?
Usually male.
Mateo. This one, Mateo.
Matteo is only male.
Male. Oh, I'm here. Hello?
I try to reconnect. I hear the microphone. I'm not using the microphone, but
Okay.
left and now return. Come back.
Mattia, Mattia, we hear only the noise of the microphone, but not your voice.
Can you speak closer to the microphone, please? Come closer to the microphone. Come closer to your microphone. No, not yet.
No.
We don't hear anything from you. Can you hear us? Mattia, can you hear us? Kindly confirm. Can you hear us?
Or write on chat box.
Yeah.
So that was the article, but now.
Mattia, can you hear us? Mattia, can you hear us? Can you confirm, please? Okay, you can hear us, but we cannot hear you. We cannot hear you.
Mattia, no,
No, we cannot see you. We cannot see you, Mattia.
we heard only the noise, the first noise of microphone, and then you shut out.
Okay, and then all done. What time will 11:30, right?
Yeah.
I mean, the next keynote.
Mattia, Mattia, we hope that you are asking, but in 10 minutes probably we due to go and go to the next session. So if the problems haven't solved, we no, don't worry. We talk with the technical assistants and we move in another session, hoping that the problem will be solved. Okay. We talk with the technical assistant, Mattia. Thank you.
Okay, so sorry, folks. We have some technical problems.
So we close.
Okay, so that should have been the third and last paper of this session. Then, okay. Thank you very much. Around and then let's wait for a while and then go to this keynote speech. Starts at 11:30. 11:30, right? Keynote.
Yes.
11:30, 12:30.
No,
The keynote.
keynote.